hello everyone. So yes, my name is Jenn Creighton. I am a senior software engineer at Netflix. I'm active on the Twitter. My handle is girlcode, girl with a U. So definitely feel free to reach out to me, grab me after this talk, come talk to me. I really like meeting new folks at conferences, one of my favorite reasons to be back in person. And unsurprisingly, you see the title of this talk. We're going to be talking about debugging async JavaScript. Now, there are a few focus areas of this talk, and much like async JavaScript, we're not going to be going in order. We're going to be hitting on these kind of loosely throughout the talk. We're going to be talking a bit about why debugging asynchronous JavaScript is so difficult. I think it's particularly tricky, and there are some reasons for that. We're going to look at some common pitfalls that I have seen and accidentally made myself, and if we look at them, maybe we can avoid them in writing our code, make things a little bit easier for us in the future. And then we're going to look at a couple of just debugging options, like how I would start to debug some of these things. How can we figure out what's gone wrong? Now, to kickstart all of these topics, I'm going to be showing some examples of async bugs. And if I show you some code, and you don't know what the answer is, like why it's happening, do not worry, right? This is not a quiz. But some of you are actually going to know. You're going to know immediately, right away, what's gone wrong, right? And if that happens, I want you to do something for me, okay? I want you to ask yourself, how do I know that? Not why is the bug happening, but how do you know? How do you know that that's happening, okay? And I'm going to come back to this soon, I promise. Moving on, though, let's get started looking at some actual code. And in this contrived scenario, we are tasked with retrieving a config file and maybe validating a property on it, right? And our coworker lets us know that there is a function that we can pull in to do this for us. And so that's what we're going to do, right? We're going to pull in this function. It's called getConfig, and we're going to use that. And we're going to call that function, expecting it to return the config to us. We're going to try and log that out. OK, it doesn't work exactly how we thought. We get undefined, right? And the first thing I'm going to do when something doesn't work as expected is I'm going to look at the thing that I'm actually trying to run, the getConfig function. And by the way, there is no documentation here. So I'm actually going to look inside of getConfig, and here's what I discover, all right? getConfig takes a function, tries to read the config file, and then it's going to receive back some data, and that data will be the actual config file. And then it's going to call that function with that data, okay? So this does not work how we expected. And honestly, it kind of sucks that we have to pass in a function here. So maybe we can actually modify this code to return the config like we expected. And we're going to do that by creating a new variable. When we get the data, we're going to assign it to that variable, and then we're going to return the config. And when we run this, we get undefined. Okay, we still get undefined. This example is really loosely based on something that actually happened to me a few months ago. And I've changed several of the facts here, but I did need to use a function to retrieve a config, and when I ran it the first time, I did get undefined. But unlike this example, when that happened and I looked at getConfig, I knew what had gone wrong immediately. And I would not be surprised if you knew immediately what caused the problem here. But again, how do you know that? And I want you just to hold that thought for a little bit longer, because in this contrived example, we do not know, okay? We're trying to find out, which means that we need to debug. And when I need to debug, I still reach for console.log. Okay? I think console.log is great. Yes, clap for console.log. It has served us well. Okay? There is no shame in console.log, right? It is a very quick, simple way to get some more information and help you debug. And I promise you, I'm going to show you the debugger in later examples. I love the debugger too. But the debugger is really a separate tool, and we choose the tool for the job. And that's just as true in debugging as it is in writing code, okay? And for this job, console.log is really just perfect, okay? I want to know a little bit more about what's happening in this function, right? I want to know what is the value of the data when it's received, And then I want to know what the value is when it's assigned to the config variable. And as I do this, right, I am expecting it to come back in this order. 1, 2, data, config. What I'm actually going to get, though, is 2, 1. I'm going to get the config, which is undefined, and then I'm going to get the data, which is an empty object, and I expect that. My config is just an empty object. And again, if you don't know why the order is off here, that is totally OK. But this is where I would realize that this code is not synchronous. Okay, if I didn't know that before, I do now. And how do I know that? I've seen this before. Okay, I have found that most of the time, the answer to how do I know that really just boils down to some version of that. I've seen it before, or I've worked with it before. And if you knew, that is likely the answer you also came up with. If you have worked with Node to read a file, then you know that read file is asynchronous. In the real version of this example, when I called getConfig and received undefined, that's how I knew what had happened. I've worked with Node before, and I know that read file is asynchronous. I knew I had mistaken an asynchronous function for a synchronous one, right? Or maybe you've worked with asynchronous callbacks before, and I say asynchronous because not all callbacks are. But that could have been the information that clued you in here. Or maybe you didn't know until you saw this. This is a big clue, okay? It's something that I've internalized through many years of debugging. An unexpected order means that some code somewhere is asynchronous. And knowing that is really half the debugging battle, which is why debugging async code is tricky. You might not even know that you're working with async code. You might write code like this, not knowing read file is asynchronous. And by the way, let's step through this function so we are all on the same page about what has happened here. First, we're going to create that config variable, all right? Then we call read file. And since that's an asynchronous function, it starts, but it does not block the following line from executing. And that next line is returning the config variable, which was never set, and so its value is undefined. And then meanwhile, read file receives the file and calls the callback where the data is assigned to the config variable, but it doesn't matter because the outer function already returned in the previous step. Okay, so that's how we get an undefined config, even though the file is read. The data does exist, but we're not waiting for that data. That is the bug. And notice that at no point are we getting an error message. Why would we? This code is incorrect, but valid. Bugs can be broken down into a couple of categories. Okay, so syntax errors, those tend to be really quick fixes. Runtime errors, maybe not so quick to fix, but at least you have errors to guide you. But this, valid but incorrect code, this is the most difficult category. Okay, here's another example. We're going to undo our past work on getConfig, and instead of attempting to return the config, we're going to wrap read file in a promise. And by the way, just to note, there are ways of reading the file synchronously in Node, as well as already promisfied read file, but let's pretend we aren't able to do that at this point. Okay, we're going to have to do actually the legwork ourselves. And that legwork is really just returning a new promise and resolving when we get the data back, right? It's not too much. And then let's run this and see if it actually works how we would like. All right, we're going to call getConfig, and we're going to attach a .then handler, which for now is just going to log the config to the console. And when we run this the first time, we see undefined. Okay? Now here's the thing. This should work. This should work. Absolutely. If you saw the previous example, you're like, why is this not working? Let's break out our handy-dandy console log, okay? Let's log out the data. What do we get? Undefined. Okay, so knowing this, the first thing that I'm going to do is I'm going to make sure my config file exists. And guess what? It does not. When I undid my previous changes, I accidentally wiped away the config file, okay? This has happened to me before, and it's obnoxious, okay? But here's the thing, did we get an error? Well, let's actually log out the error and see if we got that. And yeah, We did, okay? So this actually makes sense. We got an error, no such file or directory. But I want to be really clear here. That's not the bug. The missing config file is not the bug, all right? The bug is the silent error. When I wrote that promise, I made a really classic mistake, okay? The promise resolves the data, but it does not reject. So when read file can't find the file, it returns an error. But I don't know that. No one knows that, okay? It's been silenced. And silent errors are the worst, okay? Something's gone wrong, but no one knows. And this is super common in async JavaScript because, again, this code is valid. It works until there's an error. So just really quickly, let's fix this. We are going to get the reject function, and then we're just going to use a quick if-else to decide when to resolve and when to reject. So if we have an error, we'll reject with the error itself. Else, we're going to resolve with the data. And then, of course, we're going to see if this works by calling getConfig again. But instead of a dot then, we're going to attach a dot catch, which is going to catch the error, and then we can log a more helpful message to the console. And when we run this, we actually get what we want, okay, this time. So the promise is rejecting, we catch it, and we log the error message. And this looks good. So always reject, okay? It is a best practice. Follow it. It is going to make debugging so much easier for you. But I should note that there are so many ways for error handling to go wrong in asynchronous JavaScript. These bugs often fall into the valid but incorrect category. Let's look at another fun but infuriating example. Let's say we're building an application where a user can RSVP for an event. Okay, that's what this function does. And it also returns a promise, and it is already handling errors with .catch. And our current task is to add some UI that shows a schedule of the user's various events. So let's add a .then handler so that once the RSVP resolves, we'll update the UI. This is and is not a good idea. Okay, so we actually do need to do this, but written like this, we've actually created a bug. Unlike the last time, though, I'm not going to use console.log. I'm actually going to start to use the debugger now. Normally, for a very small example like this, I may not use the debugger, but I do want to show you what it looks like, and I want to show you one of the great things about it for asynchronous code, which is that it helps offload the mental weight of thinking async. There is an extra mental tax when we write or debug async code. All right? So as humans, we like things to be in order. So A, then B, then C. A, then B, then C, then B, that's kind of weird. And with logging, you're actually still doing a lot of these mental gymnastics. You're keeping track of what got logged when and where, and at some point, the mental tax is just too high, okay? This is no longer effective. And this is where the debugger can come in and help us. Unlike logging, the debugger can pause execution, right? So it allows you to inspect the state of an application at a certain point, and then from that point, you can actually step through your code line by line. So you're actually essentially taking asynchronous code and looking at it as if it were synchronous. So it really helps with this mental tax. So we're going to take a look at this in Chrome DevTools, and at first, I'm going to show you the way that this actually works. This code actually does work in one case, right? And under the Sources tab, I have selected the file where the code runs, and I'm going to set a breakpoint at line 15, which is where the RSVP function is called. So I set that breakpoint, and then I'm going to click the button, which is actually going to run the code. Execution pauses, and now I can start stepping through the code. And as I do this, you can see that there is a call stack on the side. And when I get here, I can see in the call stack that I've actually hit the promise.then, which is expected, right? This code actually is resolving, so we expect this to run. And then I can step into this function to see what's actually going on, make sure it's getting the correct value. Yes, it is. It's getting 1, 2, 3. Great. And then I can keep stepping through until the program exits. So all is well in our world here, right? This works. Let's break it, okay? I love breaking code and seeing what happens with it. And I have modified this code so that the promise returned from that function rejects. And so what I expect is that the .catch is going to run and the .then is going to be ignored. So I'm using the same breakpoint as before. I'm going to start to step through. And here you can see we've hit the promise.catch, so it's in the call stack. Okay, that seems fine. Let's step through again. Ooh, okay. We hit the .then. And you can see it, 1 in the call stack, and then 2 over where it's actually calling the add event to calendar, right? So as I start to step through this, you can see that in the UI, there's an error message, but also the event did get added. So this is, again, another example of valid but incorrect, right? And it is not unreasonable to think that since .catch is ignored when a promise resolves, that .then is ignored when a promise rejects. This is actually completely true. But it's also true that the order matters. Okay, so .thens after a .catch are actually still going to execute. So to fix this, we actually just need to move the .catch to the bottom, okay? And now when the promise rejects, .then will be ignored. This is one example, one small example of how error handling can go wrong. I haven't even covered anything to do with throwing promises, rejecting in timeouts, try catches and async await. I mean, there's a lot of options. And speaking of async await, I consider it this like sort of strange but lovely addition to asynchronous JavaScript. It can make writing async code so much clearer, so much cleaner, but it also can introduce some issues. This example is promise-based code. And when we want to convert this to async await, we might want to do something like this. Okay, an async function awaiting promise 1 and 2. What's the problem here? Well, the problem is that our promise-based code and our async await refactor are not equivalent, okay? And this might actually be fine, but we've taken code that did not block, so those 2 promises in the previous example ran in parallel, and we have now changed it to code that blocks. So await always blocks. It blocks until a promise resolves or rejects, okay? There are some really core differences between promises and async await, but the biggest one is that promises are non-blocking, and async await can be both. Okay, so async functions by themselves are non-blocking, but then await inside of it is the blocking mechanism. Also, like async functions return promises, and so the reason I call it strange is just that it is this intermingling of this async and sync world. You kind of have to keep changing your mental model for how things work. It's that same mental tax that I talked about earlier, and it can just be a lot, okay? It leads to a thing that I call what does what and when and where, okay? So what this means is that you need to be familiar with all the ins and outs of various async structures in JavaScript, right? That is promises, async await, that is callbacks and set timeout. Okay, there are a lot of different ways for things to go very wrong, and these things all have different rules and mechanisms behind them. Keeping this all in your brain, all at once, is impossible, okay? Mistakes are just really bound to happen. And here's one that I've done more than a few times. Okay, so I have written this very tiny little application that fetches some posts and just lists their titles, except I'm not seeing the data show up in the UI. Now, the first thing I'm going to do is that I'm going to check the network tab, and yes, the data is coming back. So that tells me something is wrong with my code. And we're going to set a breakpoint, because I know that the data is coming back. I'm going to pause execution at line 12, because I want to make sure that this was set properly. Now, when I run this, results is going to be undefined, but I actually expect that because we actually haven't stepped over fetch post yet, and stepping over a function will actually run that function without going inside of it. So now I step over it, and I can see that my result is a promise. Okay, so I've done something really silly here. Async functions return promises. Sometimes when I am working with async await, I get so used to the format inside of async functions where you can treat promises like they're synchronous that my wires just get crossed, and I forget to switch back into promise mode when calling the function. And this really drives me up a wall. And so, of course, I'm going to fix this by calling fetch post. I'm going to attach a .then handler, and then I'm going to set the post. And now we're good. But as I said, I've made this mistake more than once, and not because I don't know that async functions return promises, but because, again, this is a lot to keep in your head at once. The good news is that I'm able to debug this relatively quickly, okay? If I didn't know why this happened, if I hadn't experienced it before, it might be more difficult to debug. And there's one debugging tool I really haven't talked about yet. I think it's the best one. And no, it is not TypeScript, Alinter, or Test, though those are all very good, and you should absolutely use all of those. Your best debugging tool is knowing something well. And knowing something well cannot come from memorizing the spec, okay? Knowing something well is actually about experience. So going back to the start of this talk, that question of how do I know that? I said the answer often comes down to experience, and I really want to add on to that. Because going a step further, that experience might be, I've worked with Node, and I know read file is async. Or it might be, these logs are not in the order I expected. And the first one, I know read file is async. That is just straight knowledge, okay? But that second one, where do you get that from, right? How do you build up on that type of knowledge? It's not in the spec, it's not in the documentation, right? That is hard-earned knowledge from seeing things go wrong. And as you go along in your career, as you debug, you will naturally start to build up that knowledge. But if you are struggling with a concept in particular, like, say, debugging async JavaScript, I suggest be the bad dog. Okay, first, on a personal level, I believe all dogs are good dogs, okay? But this concept was introduced to me by a yoga instructor, and she wanted to teach us a certain pose properly, and to do that, she would teach us the pose with the correct alignment. And then she would ask us to be the bad dog, or in other words, do the pose with the incorrect alignment. Am I now perfect at yoga? No. But I do know what it feels like when the pose is off and I can adjust much more quickly than before. I get that same value when I apply this concept to code. So I have struggled with async JavaScript before, and I realized that all the tutorials I was reading, trying to get better at it, one of the problems was that those tutorials were never being the bad dog. I was only ever seeing things go right and not what they look like when they go incorrectly. So if you are struggling or you want to learn something really well, be the bad dog. Learn the ways it can go wrong and what those look like. You are still going to make mistakes and there will still be bugs, but it will be easier to fix those mistakes and find those bugs. And isn't that what we all want? That was a lot, very, very quickly. Thank you for listening and for being here.